Good morning. Welcome to the second day of NESI B15. I think everybody's probably been through the drill, but I want to just, for people who are coming for the first time today, if you want credits, there's sign-up sheets at the back. And for AIA, BPI, GBCI, I think there's an additional one. And also, there are evaluation forms, which are really important to NESI and to the speakers, so please fill one out before you leave today. Let's see. There is a special presentation today at lunch. Ted Benson is speaking at 12:30 to 1:45 in the Beacon Hill room, and everyone's invited to attend that who's attending the conference. And the closing forum at 4:30 is 100 years of experience, and that should be a really exciting session. Usually those are great, so please stay around for that. Welcome to the Community Energy Footprints, Taking Residential Efficiency to Scale. We have a panel of 4 speakers today, and the presentation will be in 3 parts. As those of you who are local know, Massachusetts has become a real leader in the nation in terms of energy efficiency improvements and energy policy. That's through great leadership and through code, and also through incentive programs. And through these programs, towns and cities have made really great strides in improving their performance, their energy performance. But to reach our targets for reducing greenhouse gas emissions and to avoid the really dire, worst consequences of global warming, we have to reach much farther than cities and towns and bring that to the broad swath of residential and commercial construction in the country. In Massachusetts, that means mostly dealing with existing housing stock because we're pretty built out here. So this session is going to look at tools that will move us in that direction and also explain the nature of that problem. Have we started up? Oh, thank you. Okay. It's an alternate pointer. Okay. So we're going to be presenting in 4 parts today. Henry MacLean and J.B. Clancy. Have you started the video? I apologize.
This
Technical
is a
issue.
PDF?
Yes.
No, it is PDF. Yeah.
Okay, I'm not doing slides yet, so.
Yes.
But are we recording?
Have you started yet?
Yeah, I started, but it's okay. I was just introducing. These guys are going to present.
Okay. Yes, we're recording. We're good to go. And, okay. All right.
Thanks. Apologies. Henry MacLean and J.B. Clancy are going to start off with a case study on the town of Milton, demonstrating the real progress that they've made in the town and the challenges that lie ahead. Then Keith Burrows will follow up with a presentation on an operational rating system for houses he's developed as founder of Resynergy. Sorry. Okay, you want to take care of that?
Yeah.
Okay, and then Brian Butler is going to wrap up with his energy rating plugin EnerScore. Henry, who seems to be our tech guru here today, Henry is an architect and an educator, and the principal of the firm Timeless Architecture, and he's also teaches at the BAC and is the chair of the Town of Milton Energy Committee. He lives in Milton, and So he's been very involved in Milton's efforts in that capacity. J.B. Clancy is an architect and partner in Albert Reiter and Tittman Architects in Boston. And his focus is on residential architecture and sustainable design. He's also a passive house consultant and has designed a certified passive house for Habitat for Humanity in Vermont. Keith Burrows is the founder of Resynergy Systems, which is a startup focused on the development of an operational rating system for homes based on benchmarking energy use intensity. And he has a really diverse background as software engineer and degrees in management, computer science, and had a Master of Design Studies from the BAC. So he's bringing his broad experience to this effort. And Brian Butler, who's wearing two hats today, is a general contractor. He founded Green Building in 2007. He's currently both working in construction, but has also is currently CEO of Enerscore, and he is going to be talking about that program, and he's also an accomplished musician. So please welcome our four panelists. We will have some time left over for discussion and questions at the end of the session, but if something's unclear or something comes up in the process, they've said feel free to ask questions. And thank you very much.
Thank you, Laura. Welcome all. I'm Henry. Let's see, can we see a show of hands of the builders in the room? One behind. Architects? Okay. Code officials? Town officials? Okay. Others? Everybody's here? Okay. We almost have an introduction by everybody. We got a small group, but we're starting late, so we'll move right along. Thanks for that big introduction, Laura. That's helpful, and so I can just going to skip a few slides here as well. Let me jump right in here. This is the standard AIA credit. If you're here, just make sure you get your credits. Copyright. The subtitle of this was by Matt Root was for all the non-net zero energy homes out there. Many of us have been focusing on this whole issue of something like 80 to 90% of the buildings that are here today are going to be here in 2050 when we have to have these goals of potentially 80% reduction. So this is a little more description which is in the handbook about our workshop, and I'll just read through the objectives of this session. We'll be learning about the baseline energy consumption of a home and a community, how they're established. We'll learn about percentages of a town's carbon footprint, and how that relates to various building types and energy uses in the town. And then we'll be exploring pathways to achieve the energy reduction goals set forth in agendas like the Mass Clean Energy and Climate Plan for 2020, the Architecture 2030 Challenge, and through the process of One Massachusetts Green Community, our little town in Milton. And then we'll be looking with Keith's work the operational ratings for residential buildings and how these type of assessments can be used to reduce energy consumption in our buildings and communities. And then finally with Brian, we'll be looking at the asset ratings and how they form the foundation of a relative performance baseline and provide key measurement verification of the cost-benefit improvements to help energy efficiency programs be more effective and accountable. The background Laura just gave us on who we are and what we're doing. So this is a pretty interesting graphic looking at the scope of the problem, and for us as architects, builders, and building professionals, we're engaged with about 41% of the energy consumption patterns of this country, probably internationally too, it might be a little more or less, and residential alone at 22% of the problem and the potential solution. Homes in Massachusetts make up about 2.5% of the residential slice of the 113 million homes in the country. And Milton is just a tiny town. We'll be talking about 9,000 households, just that tiny sampling of the Commonwealth. Massachusetts has retained that position, I believe, for the last couple of years as being the most energy efficient state in the country. And a lot of this was set up back in around 2000. 7, 8, 9 with some legislation, a bunch of different acts that set up the Green Communities Program, and what we have is the Clean Energy and Climate Plan for 2020. And that required a statewide limit on greenhouse gas emissions of between 10 and 25% below the 1990 levels for 2020, and on the way towards 80% reduction of emissions by 2050. So that 2020 goal has been set for about 25% reduction. And we'll be talking about how we're approaching that. It's a little washout slide, but this gives you an idea of where Milton is. This is Dorchester and south of Boston, and this is the whole metro Boston region. And you know, there's 3 rivers that feed the Boston Harbor, and this is a plan done by interns over Sasaki talking about what's potentially down the road with 2020, you know, business as usual, with potential severe storms. And of course, we're right here in Milton at the mouth of the Neponset. We're sort of cognizant of this, and this is our flood zone running right through the 200-year flood line with 30% of elevation above sea level. I happen to live, I don't like to admit it, but right about here. JB, you're up here somewhere. He's a little higher, but I'm at 40 feet. 40 feet is pretty high in the Boston area. Of course, we got about 8 feet of snow right now, so if you count that, we're even lower. But anyway, so that just gives you an idea of the context that we're dealing with. So the Green Communities program was set up to help all 351 Mass cities and towns find clean solutions, and this whole process of becoming a green community started back in 2010. Right now, there's about 39% of Mass communities are designated. This is the most recent map of 136 that have currently met the protocol. And these are the criteria that we basically had to get adopted at town meeting back in 2010. Yeah. Time flies when you're having fun. So anyway, the first one is provide the as-of-right siting in designated locations for renewable. We did a major project in Milton of trying to get a 4-kilowatt wind turbine up on the golf course there, which actually died an unruly death in Supreme Court, and we've now switched over to talk a little bit more about the 5-megawatt system that we're thinking in solar at this point. But so the second was to adopt its expedited application permit process for as-of-right energy facilities. The third, which was sort of the big element we'll be talking about, is the establish this energy baseline reduction of 20% within 5 years. Currently, I think there's about 6 or 7 towns that have done that. And then purchase only fuel-efficient vehicles. And then the fifth is set requirements to minimize life cycle energy costs, basically the new stretch code. So those are the 5 criteria that were all passed after some work. Just to give you an idea, for those of you who are not from Massachusetts, how many not outside of the region? Okay, good. So these are some of the programs. Energize Connecticut, Efficiency Vermont, Efficiency Maine, NYSERDA in New York. There's a Northeast Energy Efficiency Partnership called NEEP. I think they're headquartered here in Boston, but these are just all the different organizations out there working on home, efficiency programs and community efficiency programs, depending on the state and location. So I want to look those up. A little bit more about what we went through in Milton, working with a town planner, and we got this DOER designation as a green community back in early 2011, once this was all adopted and submitted, and that resulted in about $170,000 worth of incentive money for the town towards efficiency and renewable energy projects. And we're now in the process of completing our 2014 annual reporting and looking at numbers double that possibly with DOER and utility incentives and rebates on the way. So it's significant dollars for a small town. The program that was developed by the Green Communities Program is called Mass Energy Insight, and it's an online tool that basically allows all these communities to look directly at the energy use broken down by facility and departments throughout the town so that we can go through and kind of see where who's using the most energy and what can be done the best towards resolving that. And we'll look through some of the charts. As I mentioned earlier, there's just a few communities who've met this 5-year reduction. We met it actually, and we've jumped through it and back up again. I'll show that to you in a second. But again, this tool is available to all communities in Massachusetts, whether or not they're in a green community. Yeah.
Yeah, Henry, when you say town energy use, are you meaning the buildings owned by the town?
Correct, the municipal. Yeah.
Building?
Yeah, and we'll talk about the difference in a second because we actually did a whole town view of this as well.
Okay,
Yeah.
so town with a capital T.
Correct. Right. And it's very hard to see, but school buildings, which are the major McGill in the room in terms of energy use, about 70% of the town's footprint, about 703,000 square feet, have an average of about 69 kBTU per square foot, and we'll talk about rating systems now. That is the EEI standard that everyone works with, is BTUs per square foot, and Keith's going to talk a lot more about that, but we've had 2 schools that achieved Energy Star rating, and Milton was sort of in an unusual situation in that we got a bunch of grant money back about 5 years ago that allowed us to rebuild most of the schools in town. And so that gave us a big leg up. And you can see this is the Mass Energy direct data using overall use, starting in the benchmark year, which we could select 2008 in our 5-year period, then ran through 2013. I've skipped a couple of years here, but just so you can see the major fall that happened between 14% 2009 down to 34% reduction in 2012, and a lot of that had to do with the fact of the recession and things were slowing down, and also weather. And if you look at the next slide, this is the weather normalized data, which looks more like this when we actually look at the real numbers. We started with a baseline of 83,075 MMBTU, which down 13% reduction in that first 5 years, with another 4% in the solar, which is again carbon avoiding, so they're counting that as well. That got us to about 17% reduction by 2013. In the next 2 years, with the robust winters that we've had, as a matter of fact, that this roof up here, PV 28 kilowatts put on the town hall, just had a structural failure yesterday with 6 feet of snow on it. I think a handful of these corner panels just fell off, so we're working on that. We're probably not the only town dealing with that issue. But we had about a 19% reduction in the 2014, and then adding the solar, it's down to about 23% in 2014, so that's where we are right now. We're on the books, we are planning right now for a 5 megawatt PPA solar system in Braintree that would have a huge impact, in fact, 24% reduction, which would push us to about 47% reduction in 7 years, which is pretty amazing. So JB is going to take over from here.
So as you rightly pointed out, the data that Henry was just presenting was just for the municipal buildings in town. So one of the things that our alternative energy committee in town wanted to do was to understand what the total carbon footprint of Milton looked like, and how the municipal buildings, which we're all focused on, related to the overall energy consumption of the town. So in order to kind of begin to understand that, we looked toward organizations outside of Milton, and signed up, became a member of ICLEI, the International Council for Local Environmental Initiatives. They had established a protocol through which towns and cities could create a greenhouse gas reduction plan. And they also provided support and software through which we could begin to baseline the town's energy consumption. So you can see here, this slide shows kind of protocol they set up in terms of these milestones of how a community like ours might go about creating this greenhouse gas reduction plan. And obviously the first step in any effort to try and reduce your energy consumption is to understand how much energy you actually consume. how do you go forward on this? Just the arrow? Yeah.
There it is.
Okay. So ICLEI made available to us a software called the CACP 2009. Essentially, it was just a sophisticated, CO2 calculator. But that allowed us to begin to go and catalog all the energy consumption of the town. And what it would do is it would actually then calculate CO2 emissions based on the inputs. So whether we were putting in kilowatt hours or therms or vehicle miles traveled, it had factors that it used looking at the kind of upstream energy consumption for those elements and giving a CO2 equivalent to that energy. And you can see here, the value at the bottom, which we'll kind of talk about a little more. So once we went through, and I'll show slides a little later that shows some of the input tabs, but once we went and cataloged all the town's energy consumption, you can see what the town looks like. And the municipal part that we were talking about before is just that tiny little slice on the bottom, the 2.2%. So Milton is a town made up of 9,000 plus households, most of them being single-family houses. So residential energy consumption is, the majority of energy consumed in the town. The other part of Milton that is quite significant is transportation. Although Milton does have commuter rail lines that run through it, public transportation, a lot of people in Milton drive. According to the census data, about 80% use their cars to get to and from work. So vehicle miles traveled was a significant component of our town's energy consumption. We also have 3 miles of 93, which cut through Milton. We did not calculate the vehicle miles traveled in this calculation because that was essentially 231 million vehicle miles traveled, and it really would have skewed the data, and we didn't really think it was fair to our town to try and account for 93, although ICLEI kind of wanted us to do that because I think they felt like if every town did this protocol, they would then understand, what the total kind of energy consumption of, say, 93 might be. But we just took travel modes originating and ending in Milton, and we worked with the Department of Transportation to get that data. Like all kind of work like this, it's both an art and a science. And, there were certain things that we would rely on a state agency for estimates. They would look at the number of miles of street and congestion and then apply factors to it and give us information on vehicle miles traveled. But again, the significant thing here is just how small the municipal footprint is. So as Henry showed, if we achieve that 20% reduction for the municipal component, how would we begin to address the bigger piece here, which is the residential component? So as I said before, of buildings in the town, a majority of them are single-family houses. And that's about 80% of all the emissions from all the buildings. We have a small commercial footprint. Tiny. Over 20 million square feet of housing stock in Milton. So of those 9,000 households, there's about 20 million square feet, which is a significant number. So this is just one of the inputs from kind of ICLEI, and again, you can see here the kilowatt hours, therms, and such. So like I said before, the art and the science component, the science part was, we could call up NSTAR, and they could tell us the amount of kilowatt hours coming into the town because they know exactly at 1 meter how much energy is coming into the town, and that's metered residential and commercial. So we had a very precise number we could input there. The same was true with natural gas. But number 2 fuel oil was something we had to kind of find our own way of estimating. And we took the assessor's data, which actually has a category for fuel type, and calculated all the square footage for houses that use number 2 fuel oil and assigned an EUI to that per square foot, and then tried to estimate MMBTUs off that. It's actually a smaller number, and in terms of square footage, is a smaller percentage of houses in Milton. Most of them are natural gas. But that was one that we, felt like we didn't really have as accurate a way of calculating. The commercial, a little more precise because we have the kilowatt hours and the therms. And then we also took the information from Mass Energy Insight and also put it into the same ICLEI software. So again, just this is really just a sophisticated CO2 calculator, and it asked for things like traffic lights and street lights and such, which we were able to get from the Mass Energy Insight software, which is a pretty phenomenal program. All that information is really pushed into that program on a monthly basis. So for any town, Peregrine is the company, yeah. So for any town or city, once the accounts are logged in, it's just constantly updating. So again, here's that snapshot, just not in a graph form. Again, the residential footprint is the largest component, with transportation close behind. So like Henry said, we've been focusing on the municipal part, but if we really wanted to think about these climate reduction goals that Massachusetts had set forth, we needed to look beyond just the 2% load of municipal buildings and start to address the 20 million square feet of residential. So if we applied, that same 20%, what would the savings look like? And you can see it's 18 times. It would be an incredible number. So if Milton was able to do the same thing it was doing on its municipal buildings for all the residential buildings, now we're actually talking about some real gains. So as I said before, 80% of the residential stock is houses. Almost 9,000 square feet of units in town are 20 million square feet, which is a lot of energy. Using the ICLEI CACP values and applying that to the square footage, we came up with a value in EUI of 72.7 kB2 per square foot per year, which is kind of what we expected for the existing housing stock. So what we decided to do was try and kind of launch some kind of public campaign to weatherize as many houses as we could in town to try and reach that 2020 goal. We sent out a flyer to about 3,000 households. We had a public kind of information session at the library, partnering with Next Step Living and Sustainable Milton to try and weatherize as many houses as possible. Next Step had set a goal of about 600 houses per year. And if we were able to do that every year to 2020, that'd be about 3,000 houses, which would be significant. And what was the expectation of, could we actually reach that 20% that we were just talking about? And, we did some kind of back of the envelope calculations in terms of what the expectation could be using 70 kB2 per square foot if we had a 15% reduction in the envelope, 3% HVAC, lights, PV. 20% seemed like it could be achievable. And Henry and I have some experience that kind of backs that up. So the 20% goal isn't something that seemed too far out of reach. The challenge actually would be getting the 9,000 households to participate. And even at 600 households a year, we're not going to get there. And really the burn rate is more like 100 to 200 households per year, given their experience over the past couple of years. So the kind of public campaign and the advocacy part is the bigger hurdle than the technical part. The technical part, this seems like it's within reach, with air sealing and insulation and efficient equipment. One could, achieve it. It's getting people to participate. This is just using some of the data from Next Step Living and looking at, based on values that they're estimating, what the actual savings is, and we're actually showing about 20% given their measures. So, like I said, if we have 9,000 households and we're only getting 110 a year, it's going to take 82 years to get to our goal. So that's not really going to work. So our challenge is more on the advocacy part now. This graph just shows, going beyond the 20% reduction, the other kind of concepts that are out there. Net zero, people have obviously been talking a lot about passive house. And this is just another confirmation of, is 20% achievable? This is my own house kind of measuring air infiltration and energy consumption when I pre and post insulation and air sealing, weather normalized. And I was showing an over 20% reduction in both energy consumption and air infiltration. So again, the 2020 goal is of 25% is a good one, but we all know that, there are bigger challenges out there, especially set forth by Architecture 2030 or even by the state. And there are technologies that are out there too to achieve that, passive house or net zero energy buildings. So really, even this first step is really just a small step, because the bigger challenge is really getting to much greater energy reductions. And this is a passive house that I designed in Vermont for Habitat for Humanity. It's measured and monitored, and we are showing 80 to 90% energy reduction in this building. So again, the technology is there, even for these dramatic reductions in energy consumption. It's really just getting adoption. That's going to be the big challenge.
And just a final couple slides here, and just to mention one thing. Next Step Living, we determined, was doing about 60% of the, what we call them, home weatherization programs in Milton, actually in Boston. So that number, 82 years, we think is probably closer to maybe 50, but because there's another 40% in there that. And just as another house that, just a typical house in my house actually, that I've got about 18 years ago and did some work on, and my office is there, and we went from about 1,600 square feet up to 2,590. So this is kind of a typical house in a way, because a lot of these homes that we build out, and the basement is completely redone, and so energy use was 90 kBtu per square foot. We got it down to about 45, which is a net 20% only drop, really, because if you add the square footage. So this is looking at, just a typical house. Some of the things we did inside, and this is all pretty standard. But, and this is a house that DER over in Quincy that we completed a couple years ago, and this met the 1,000 home challenge threshold, which got us down to about 11,000 kilowatt hours a year, or about 8,500 BTUs per square foot per year. So this is just where we can go. It's the house up there. Again, we added square footage to this bungalow from a 2-story to a 4-story when we used all four floors. And just a final slide showing that, these deep energy retrofits can happen at all different scales. That Quincy house on the top, and then this is the Boston South End 192 apartment building, unit building. Building Science was involved with, Building Science Corp., which has about a 72% reduction in energy use, and then a scheme to actually renovate Boston City Hall at a large scale of about, again, about a 70 to 75% reduction in energy use there, just by reclaiming square footage that's not properly used in that building. So I'm going to pass it over to Keith, who's actually a student I got to meet at BAC doing his master's in sustainable design, and he's done a wonderful program, which is his thesis actually at the BAC, that he's going to talk about benchmarking. Thanks.
Good morning. As Henry said, my name is Keith Burrows. I'm going to talk a little bit about benchmarking residential energy use intensity and how we can use an operational assessment like this to reduce energy consumption in a town like Milton. So why is benchmarking residential energy use important? What's the need here? And I think this has obviously been demonstrated a bit by JB and Henry already. But in the U.S., residential buildings account for over 18% of total CO2 emissions and more than half of building energy consumption. And as you saw from the stats that Henry and JB provided, in Milton, that's even more, the residential sector is even more significant. It's more significant in terms of carbon emissions. We'd probably all agree that when it comes to the existing building stock, efficiency is not improving quickly enough. There's a lot of great effort that's being made, and we're certainly making progress. But when we think about the need and the peril that we're under in terms of climate change, we need to do more. And when we look at residential energy efficiency from a systems perspective, when we step back and look at how we're adjusting the efficiency of existing houses, what we're doing is we're subsidizing energy efficiency. This is how we're trying to approach it. We're spending lots of money We are increasing the supply of energy efficiency expertise, and we're lowering the cost of energy efficiency upgrades to homeowners. And we have some fantastic programs as a result of this effort, but it's extremely expensive, and we're not making progress fast enough. What I think we need to do is do a better job of stimulating demand. And if we look at the American Recovery and Reinvestment Act of 2009, $5 billion were allocated to weatherization, and we ended up reaching a milestone of 1 million homes in under 3.5 years, which is actually quite good, right? 1 million homes weatherized is great. But when you think about the fact that we have 130 million homes in the US, it's going to take hundreds of years to address these homes at this pace, and it's a significant cost. So, how do we improve this? What I think we need to do is help people understand how efficiently or inefficiently they're operating their homes. Provide feedback. And most of us don't really know how much energy we use or if that amount is good or bad. I think this room is probably the exception to this rule. But really, what most people understand is how much they're paying for energy, and we know this is an incomplete form of feedback. Those prices do not reflect the social and environmental costs of extraction or burning of fossil fuels. And so, because our prices are low, this really isn't the motivator for change. We're not actually seeing much change because of this. And the management consultant Peter Drucker famously said, "If you can't measure it, you can't manage it." And this is certainly true with energy efficiency, but also we need to put these measurements in a context that's meaningful for people, help them understand what these measurements and metrics mean. And you might be asking yourself, don't we already have a way to measure the efficiency of our homes? We have many ways to do that right now, right? HERS is a great example. It's a fantastic tool that is used to measure the efficiency of the structure of our home. So it's a great way to objectively measure or compare homes. But like any tool, it has its uses and it has its limitations. And I'm not here to bash, certainly not here to bash HERS. I think it's a fantastic tool. But there are certainly reasons why we don't see a HERS score on every single home in the United States, right? It's time consuming, it's expensive, it's not always accurate, and there's a bias in favor of larger homes. And what's important to me is that it also removes occupants from the equation. We're looking again at the structure, but the home as a complete system includes both the structure and the occupants. And HERS is a type of asset assessment, right? So it's looking at the structure, looking under a specified set of conditions, and predicting some type of energy consumption. This is also true for energy modeling. It's the same type of assessment. And locally, we have a home MPG program in Western Mass that's an attempt to label buildings using an asset assessment. And this is I love this picture. This is from my friend Wes. I think he might have been drag racing in a Prius. I'm not exactly sure. But what we have here is one of the most efficient cars on the road, operating at about 5 miles per gallon for a significant amount of time. And what this highlights is that, yes, it's important. If we look at the asset rating for this car, it's 50 miles per gallon according to the EPA. And what this highlights is that, yes, we need to understand how efficient the structure is, in this case the car, but we also need to understand how it's being operated. If our goal is to reduce energy consumption, and that is the goal, right? We're not really just trying to make efficient structures. We're trying to reduce energy consumption. We need to look at both. And the way I'm trying to do that is by benchmarking energy use intensity. And as JB mentioned, benchmarking is the first step in any kind of energy efficiency effort. So after looking at a lot of different approaches for benchmarking energy use intensity, what I decided to do is I created regression models based on statistical analysis of the REX survey data produced by the Energy Information Administration, and REX is Residential Energy Consumption Survey data. And when I say model here, it really just means mathematical formula. And these formulas will project energy consumption for a home given certain parameters. And these parameters are the characteristics that influence energy use in the home. It's subjective, meaning the parameters that I chose might be different than ones that you would, but they're statistically valid, meaning that they definitely have an impact on energy consumption. So some of the parameters that I'm looking at are total building area, which always includes the basement in this case, the year the home was constructed or last major renovation, number of occupants. This could definitely have an impact on energy consumption. Heating degree days, cooling degree days, so we're looking at climate. And then the building type, which obviously could have a significant impact on energy consumption as well. So the steps to benchmark a home, we gather the data for a particular home, which is those home characteristics, 12 months of energy use data, convert that data to BTUs, and calculate a site EUI for the home. And again, I'm looking at site energy here. Then we calculate the model EUI. We take the characteristics of those homes, plug them into the formulas, and then the result is an EUI that's projected based on the models. And then we determine what's called an efficiency ratio. We take the actual EUI divided by the model, and that gives us some indication of how that home is performing. If that ratio is less than 1, the home is performing better than predicted by the models. And what we can do is we can determine where that home's efficiency ratio falls in a distribution of homes, and we can use that to generate a rating between 0 and 100, where 0 is bad and 100 is good, something that's intuitive and easy for people to understand. So graphically, I don't want to get into the math too much here. Happy to talk to people afterwards if they'd like. But graphically, this is how we're actually calculating a rating. This yellow line is a distribution of homes, and we have 2 homes that have been rated here. Home A, what that's telling you, it has a score of 80, which means that 80% of the homes in this distribution have a higher efficiency ratio, meaning they're operating less efficiently. That's where the score comes from. So does it work? So what I wanted to make sure is that homes with high ratings weren't simply performing better than predicted by the models, but that they're actually using less energy overall. And what I did is I actually went back and rated all of the REX survey homes, so 12,083 homes, and grouped them into quartiles. And what I found is that, yes, indeed, the homes with the higher ratings are using less energy overall, and this is true for both single-family homes and for apartments or condos, you can see here. Significantly less energy. And this also holds true if you only look at a subset of that data, which is apartments or homes with 2 occupants only. That's the same pattern holds true. High rating, low energy use. So how could we use this in a town like Milton to reduce energy consumption? And we're currently working on trying to kick off a pilot program in Milton where we're going to rate a subset of homes. So it's an interesting thought experiment, like how can this help Milton in their efforts? So importantly, what we'll do is any homeowner that gets a rating for their home, they'll get the missing feedback. They'll be able to understand how efficiently their home is operating, something that they're not currently getting with their utility bills today. And this alone can provide significant motivation for change. We can work with homeowners to help them implement behavioral changes that will reduce energy consumption and improve their rating at very low cost. And we can also facilitate interaction between energy audit companies, Mass Save, and the homeowners. Help them with that process. Homes that score poorly, we can get the audit companies in there and help facilitate structural improvements. And then perhaps most importantly is we can actually verify that any changes we've done are having a positive impact. We can rate these homes whenever we get a new set of data on a monthly basis, quarterly, yearly, and actually we can ensure that we're having the impact that we expect. And this is something that's often missing from residential efficiency programs today. We may calculate participation rates, but we don't actually know what the impact is. And I think when it comes to participation rates, when people see their audit, they see that their home is performing poorly potentially, this will provide motivation to go and get an audit. And here we look at JB and Henry talked about the participation rates in Milton for audits. 210 homes in 2014. They're projecting 600 homes going forward, and I think we could really help with this effort by providing that feedback to homeowners. Studies of MIT have shown that when people have their energy use compared to social norms, we can expect to see a 2% efficiency improvement, so a 2% reduction in energy consumption simply by comparisons to social norms. So this will result in behavioral changes, and we can expect to see the same thing here in Milton. So if we look at the 2020 projected energy savings for Milton, we have 3 different scenarios here. If we end up with historical participation in the audit program with 110 homes per year, we can expect to save about 50,000 MBTU. If we get, and this is saving from the residential space only, of course. If we end up with 600 homes per year, we can save over 300,000 MBTU. And if we see a 2% operational improvement on those 600 homes, we can save over 350,000 MBTU. So significant improvement with very low cost. So outside of Milton, how else can we use operational ratings? This is a map that's highlighting disclosure and benchmarking policies in the United States. It's produced by the Institute for Market Transformation, and actually I think they're actually speaking right now at the same time. And what it does, this map is constantly changing, but it's highlighting locations where there's some kind of benchmarking and disclosure policy. And those disclosure policies are either sharing energy use information, so utility bills, or actually sharing some type of benchmark rating. And the states in light blue are residential specifically. So we could use an operational rating. We could disclose that information at the time of a real estate transaction. This could also be done with a HERS rating. I know there's some talk about this, and I think that makes a lot of sense. Someone who's looking to buy or rent a home would receive this information prior to making that decision. It would inform their decision. Efficient homes would be given a premium, and then landlords and homeowners would be motivated to make their homes as efficient as possible. And then down the road, I think it's possible we might see public disclosure of operational ratings. Certainly we'll see public disclosure of asset ratings, like a HERS index or HERS score. And what, to me, this is like the Zillow of the future would be you go and look up a house and you will see an energy efficiency score associated with that home. I think it could be an operational score. Right now there are probably some concerns around privacy with that because it is a reflection of your actual consumption. But I think as norms change, as we become accustomed to the fact that our data is out there and being used for many purposes that we don't know about, that this is going to become acceptable. It could also be used for federal and state tax incentives. So a high rating could result in some type of tax credit and would again provide motivation for efficiency. And then finally, if you're interested in rating a home, next month I will be releasing a beta version of the web-based application around this rating system. It's not available now, but it will be. And while I'm in beta mode anyway, the ratings will be free, so please go check it out. Thank you. And now Brian's going to give a little talk about EnerScore and asset ratings. And if he contradicts anything that I said, just remember that I am right.
You're both right.
Not going to contradict anything. And I think this is going to be made available on the NESI website for your consumption. And so actually there is a bit of overlap between the work that Keith's doing and a bit of my presentation and JB and Henry's information as well. Well, I guess I'll just get into it. But so we're EnerScore. We are a small team of building scientists, HERS raters, a builder, and a web coding development team. And sort of the fire in the belly for us was, just going year after year, as my colleagues have mentioned, and not seeing the needle really moving fast enough in market transformation. And so we thought, how could we put this on display? How can we make energy efficiency visible and sort of raise the discourse? I think we're in actually a rare window of opportunity right now, sort of perversely, with all the ice dams that are covering the entire region. I mean, home performance is on full display, which is it's brilliant because I'm like, this is what we want to do. You know, maybe not damage everyone's homes in the process, but it was just so enlightening to drive around and go, wow, that house sucks and that house sucks. So along the lines of Keith's last slide, you know, this is kind of where we started from at a coding hackathon, and wouldn't it be brilliant if only, you know, the elephant in the room could be made apparent. You can go to these websites, and it's all kinds of cool information about principal, interest, taxes, insurance, the classic PITI. You can learn about home security, furniture expenses, but where's energy? So the idea was simple enough. This is actually also a Redfin simulation, just showing a monthly consumption breakdown. But and also, I think Keith also pointed out how cool would it be for you to actually be able to sort your choices for housing by performance. And so, why an asset rating? And I actually don't think we contradict, Keith and I don't really contradict each other at all, and I'll get to that in a moment. Operational data is of limited value, especially in a city like Boston, with such a high turnover of occupancy. In my profession, I'm constantly dealing with properties that have gone under treatment or just been purchased, or homeowners. Most of the deep energy retrofits I've done, the back data on how the house has performed is either not available or of limited use, just because the occupancy has been very sporadic. So the analogy I use is if you were going to buy a used car, would you ask the salesman to give you a year's gas receipts, or would you just go and look up the car's EPA rating on the internet? And you know, most people are very conversant on the cost of commuting, and conversant might be a word, like bludgeoned over the head daily is probably a better way of looking at it. I mean, you're constantly in touch with what does gas cost, how many miles do I get from a gallon, and you know this like the back of your hand. So the closest parallel to that with the housing market is the HERS rating. And so just to talk quickly about HERS, acceptance of HERS dwarfs all other standards. Currently, as both Keith and in a previous session last year, Michael Blasnick pointed out, it's a flawed metric. There are some issues with it, particularly with energy cost projections. But as with MPG in a vehicle, even if your actual mileage may vary, it will vary relative to your driving habits. A home's variability will be tied to the occupant's living habits as well. What's important is that the rating be consistent and relative to all the other homes and not to all the other occupants. And so, to create a HERS rating, the energy modeling software requires some basic inputs. EnerScore's task is to come up with these inputs from afar. But we're not looking at energy bills, so what? There is an astounding amount of data available about us and our homes, a creepy amount of data. And what we thought is, well, let's put it to good use. So there are large data aggregators, CoreLogic, an enormous aggregator of data. These are sort of the for-profit businesses. There are also public resources, Registry of Deeds, local building departments. ResNet has now opened up its database of HERS ratings, the existing HERS ratings nationwide. Noticeably absent from the data set are energy bills. For the most part, you can't get them, and we really don't need them. And here's why. From public record, we can start to virtually build the house and ascertain the performance of all its components. By studying substantial enough sample group of each common typology, we start to see certain patterns emerge for air infiltration, thermal bypasses, mechanical system types, configurations, window performance, heat theft phenomenon in multis, and so on. Sorry about the notes. So pick out a typology, and attributes that are key to energy modeling software start to take shape. Drill down, year built, UIB, it's effective year built. It's a key metric that, when you have a home got renovated and the building inspector does your final sign off, he hands the building card over to the assessor to come out because, well, they want to charge you more tax money for your really cool new house. That's a great data point for us to say, hey, this home was got renovated. We can now assume that performance level was brought up to whatever the standards of requirements were at the time it was renovated. And again, as we start to drill down, we look at heating type. Heating fuel gives us a tighter range of AFUE, as average AFUE has evolved over time in fuel types. Floor number gives us important clues about the likely air leakage patterns within a typology, the so-called heat theft effects. Once all that can be gleaned from public record is taken, we look to field research done on sample groups of each home typology. So the idea being that after you've looked at 100 triple deckers, some things become evident that, every time you see kind of this pattern of thermal bypasses that are germane to that type, this type of boiler that can be expected. First floor typically will have ducting because it's easy to get to from the basement, and so on. And so a picture begins to take shape as we build the home's components. And these are what eventually, through public record and enough field research, actually build the inputs that are necessary for the modeling. So back to the automobile parallel for just a moment. It's a beautiful automobile. If we were to be talking cars instead of homes, how would you back into an energy rating for a car if you couldn't find the data online anymore? Well, you would take a sample group, gather data from each of the typologies in question, and sure, there may be minor variations in options and components, maybe a few model years range of difference, but we're going to get a pretty good sense of where that model is performing. And as with HERS, we would conduct testing under similar control conditions so that we arrive at normalized data. So as with the car, a little bit of variability within a typology group is fine. The growing body of research captures patterns and quirks that are germane, like I said, germane to each typology, reduces them to algorithms. As the software becomes more sophisticated, it can begin to handle minor variations, like what happens when somebody puts on an addition. The software takes it into consideration as it grows in its capabilities. So we start building this robust database of statistics about the existing housing stock for each typology, each range of years built, the number of bedrooms, baths, and we get better at predicting the composition of the building's components. As HERS ratings are not particularly informative for most renters or buyers, as Keith points out, a final layer of processing gives deeper meaning. Is anyone familiar with the European standard? So this has actually been codified and is now in use across the EU, and it's actually required. So EU standards now require all homes advertised for sale or lease to disclose their energy rating. The rating is also an asset rating, though it has a projected kilowatt hours per annum based on typical occupancy. So again, they are putting this back into easily digestible terms, showing you where this house stands, but also putting it into energy terms so that you can translate this to cost. And so what is it going to cost me? Being the $3,000 question. So, but probably the coolest part, the final part of my slideshow, is the ability to actually boil this down to cost and cost benefit. So our software partner Ecotrope is able to run cost benefit analyses of the most cost-effective prescriptive retrofit packages to fit each type of dwelling. A 1940s cape with its classic thermal bypass weaknesses behind the knee walls of the second floor, the in-wall radiators of a 1920s brick Tudor, the heat pouring back through the cold sheathing into the street. See this with the thermocam or through ice dams. The wind wash attic of an over-ventilated 1980s raised ranch. These are all characteristics that can be reduced to statistics and numbers that can be crunched so that cost-effective retrofit packages can be prescribed. So here we see cost on the x-axis and HERS on the y. This quality of analysis cost-benefit is achievable for so many common typologies. Wouldn't it be great if we ran our energy efficiency programs with such rigor? As with most states, the Green Communities Act's charter is to seek out and execute all cost-effective energy savings. Yet very little research into the baseline of current housing stock has been done, much less any in-depth analysis of how to tackle it. The utilities collect energy efficiency fees from our bills to provide energy efficiency programs. And there's two ways to account for performance. We can either count participants, or we can actually measure the performance improvement per participant. Unfortunately, our programs are set up to do the former. So I guess to put that into an analogy, let's say if I'm the CFO of a publicly traded company, would my shareholders be more satisfied with my quarterly report that showed that all the employees showed up and punched their time cards? Or would we be looking for a financial analysis of how the company performed? Just really doesn't make any sense. So what kind of efficiency programs do we want? Paul Eldrenkamp, a local builder and a leading member of NESE, and a well-respected voice on the subject of home performance, wrote an article in his blog titled "What's Missing from MassSave." This slideshow, I believe, will be available if you want to follow that link and read it. It's an excellent piece. Paul tells the story of a recent MassSave energy assessment done on his home in Newton that pointed out the shotgun approach to specifying energy efficiency work that is currently, sadly, the norm. Equipment that his home clearly didn't need was prescribed, and other potentially more effective measures were either glossed over or just not covered at all. But it simply doesn't have to be this way. If we choose to hold our utility energy efficiency programs to transparent accountability, we have a really strong shot at the kind of market transformation that I think we're all looking for. And that's my show. Do we have time for?
So, yeah, we have 20 minutes for, we have 20 minutes for question and discussion, and it doesn't look like we got a microphone available. So I'm going to take your questions, then I'm going to ask the respondent to repeat the question so that everyone can hear it and we have a record of it. Go ahead.
Okay. I think if you ever see someone juggle, you're bound to have someone come up and say, "Wow, that was good. Can you get fired? Can you do 6 plates to get you fired?" So, anyhow, Brian.
With that intro.
Yeah, so your energy score, you're going to be Ecotrope would come up with the most cost-effective measures. After speaking with you on the phone a couple weeks ago, I'm not sure if you know who I am, but that's I looked at the Illinois study where a lot of this was based off of, and they looked at what they did in Illinois where they took this kind of a rating for cost effective. They compared it to what was actually being put into houses. And what they found was going into houses were things that actually produced more comfort. And so people weren't offered the most cost effective, so that may have influenced them. The builders were aimed at. So I'm wondering if Ecotrope could actually then come up with a set of measures. Here's the most cost effective. Here's the measures we're going to produce the most change in comfort. Because I think that might be a really important thing to add. You may not do the most cost effective. The homeowner might spend more. You might still get the same energy savings, but you might get more uptake because you're actually aiming it at what they want. So, put that out there.
No, that's an excellent point, and it's one that, as a contractor trying to sell home improvements, especially of a performance nature, I wind up in that conversation all the time. And the sort of non-energy benefits of doing this sort of work are extremely important, but can be difficult to convey. Another aspect of it beyond comfort is health. Once we do start tightening up an envelope, you get to a tipping point where you're running into some potentially dangerous issues that are currently, again, not even really contemplated with our current weatherization program. So it's a valid criticism, and it's one that goes beyond the discussion of simple cost. However, I think the work that Building Science Corporation and other kind of durability think tanks, for lack of a better term, are doing, especially at the vanguard of deep energy retrofit work right now, are going to lead the way and show how we do this without screwing up. In Europe, Passive House, probably famously over there, I don't know how well it's known over here, started out with a couple of real bombs, man. They built a few houses that used what they call earth tubes, and they had major air quality issues where basically what an earth tube is you drag your intake air, your fresh air, through a set of tubing under the house that pre-warm at least to Earth's temperature, or cool as the case may be in the summer. And the one sort of problem with that is they grow mold, like really nasty killer mold. So that was quickly scrubbed, and they said, "Good God, let's move on from this before we scuttle the whole Passive House movement." So they did quickly adapt and adjust, but that you're absolutely right. That has to be part of the conversation as well.
Yeah, I'm thinking just as a sales, as if you're going to go to someone and tell them that, even before you do an audit, there's measures that could be very cost effective. There's ones that can produce more comfort. There's specific ones that might produce more health. And I'm going to give you a package and you can choose between them. Homeowners, purchasers love to have simple, I can do this or this.
Mm-hmm.
So if you're going to get more uptake, this you give them two choices.
I'm going to take the moderator's prerogative and just ask a quick question, which is, do you envision your program being used by utilities to help, or by other administrators of the program, to help target bad performers ahead and design programs that can actually reach out not to the people who volunteer to come into the program, but to actually reach out more in a targeted way to that housing stock that really is in most in need of improvement?
Almost definitely, and honestly, in the research and development phase of the product, that's going to be absolutely essential. Is getting feedback from our work, or the work of the weatherization crews that are actually going into the homes that we've targeted. What is working? What is giving us the maximum benefit from a dollars standpoint, but also from a health and safety standpoint.
I just want to ask, how many people were at Suzanne Shelton's presentation yesterday? Was anyone in the room there? So she did a great presentation, which was pointing out that almost no one in this country thinks that their home has an energy problem. So I think what we're looking at is ways to both drive it from from the utility side to say, who do we need to target, but also from the general population, people usually looking for purchasing a house or renting a home, you know, why should I care? Because right now we're at a point where a lot of people just think things are pretty much fine, and energy costs are not, you know, for some people they may be comparable to their cell phone bill. It's not the biggest thing that we pay for, so driving that demand requires some change in understanding.
Yeah, so I want to know if anybody is looking at that tipping point between, you know, maybe an old house with old insulation, you know, albeit not very much, and putting in new, and whether or not you're going to be causing a problem down the road. You know, when in the Milton case or any of the projects you work on, how do you establish that just right balance with the homeowner?
Can you repeat the question at the beginning?
Yeah, I think the question is, how do you establish that balance? And what is the tipping point when you're doing?
Right, you don't want to cause mold or
Right.
problems by making it too tight because the house isn't, you know, you can't get to every corner of the house, you can't do everything, you can't about all that was done before.
Right. I think with the deep energy retrofit program, what's interesting is that it started out in the pilot that we did in Quincy that I showed was it was everything or nothing. And now what they've done, because of the costs of a typical DER is probably anywhere from, I don't know, $50 to $80 to $100,000 and might pay back within, you know, anywhere from 10 to 15 years, depending on so many variables. They've broken it down so you can do one component at a time. And I think it's important that when you take an owner through a house to do that in a sense, to look at the basement as a separate, it is a whole system, but cost-wise, you're going to be incurring, you know, major components of the budget to apply to the basement or the siding or the roof. So sometimes it's good to break them apart, but as Brian pointed out, there is that point, and the consultants that we bring on board will always be determining when you've got to switch over that air system to make sure you either got an HRV or an upgraded, you know, bath fan system so that you're going to get the kind of air quality and the health issues. I appreciate the earlier comment as well, but I also wanted to point out that I think it's important to put the health and the energy issues and the comfort issues really into an integrated package. I wouldn't necessarily split them apart because I think it's important to be educating people about the fact that, you know, health is primary, budget is primary in the sense, you know, it's not an either or. So.
Well, I didn't think it was. I think
Yeah.
it'd be a lot older one.
Okay, good.
But I think it might be, the difference might be replace your boiler, that's
Yeah.
the most cost effective, but
Okay.
you're pretty uncomfortable.
Yeah, yeah.
You know, insulate the walls, you're gonna be more comfortable, but
Right.
you don't have enough money for the boiler.
Okay.
You know, I mean.
There are priorities, correct. And I think it gets back to her question too, is that where do you start, you know, how do you split it apart? So it is a little bit of
And
a...
are you doing that with your clients and homeowners in Milton? Is that happening now?
Yeah, I think it is. I mean, I think people are, I mean, I don't work just in Milton, but every client has, again, a separate series of issues and priorities, and I'll let JB address this as well.
Well, but it is true that not every homeowner would have Henry or me as part of the team. So then, you know, it is a responsibility of the organizations like Next Step Living or others to have their own quality control systems in place to make sure that the work that they're doing is done correctly and is not causing problems, you're saying, because there is the potential you're taking these old buildings that have not been insulated for 100 years, and we're now putting insulation in them, reducing the heat flow through the walls, and, you know, there is the potential for problems. So, but, you know, that I think, that, you know, Brian's point about the earth tube and passive house, you know, 10 years from now, all the work that was done has caused a whole series of problems. I mean, talk about going backward. So, but I do think, as Henry said, you know, it is hopefully the people doing the work or the organizations that are being paid by the utilities to do the work have systems in place. And whether that's true or not, I don't know.
Ventilation safety is part of the Mass Save program, and the Deep Energy Retrofit program actually requires testing of the air tightness of the home, and there are standards that require ventilation if the home exceeds a certain air tightness. So
The DER program clearly is
Right.
one that covers that, but it's the kind of
Right.
run-of-the-mill weatherization type work that.
Yeah, the run-of-the-mill people don't tell you, you don't come back.
That's an opportunity for tightening of the standards, I think.
These are one of the
Um,
people pages.
yeah.
Perhaps the one that might cause a problem, they don't recommend.
I'm going to go to the gentleman in the black jacket. Yeah.
Thanks. I'm wondering if Brian, can you talk for a minute about how they pull apart public data and how consistent it is with the challenges process, and also are you able to access records of permits pulled for upgrades that haven't done, system upgrade or wiring, what's that process like?
So actually, I'm going to let Brian address this question because my system is not using public data. It requires the homeowner to provide that data. So I think this is actually Brian's.
Two-part answer. If a permit was pulled, which is a big if, then yes, that in a lot of localities that information is available digitally. If it's an older record set that's paper-based, that's not going to be accessible. Or if work was done without a permit, well, that's why you pull permits. Otherwise, you're working at your own risk. But where it is available, there is a very rich data set. Actually, the city of New York is all online now, which is huge, and it's actually pretty rich data set. And so, again, what can be gleaned from that is only as good as what was reported on the building card at the time the permit was pulled. But where it was done well, it's very informative to the inputs to the energy modeling software.
Can I add one thing? We're just, as I mentioned earlier, we're finishing up the 2014 reporting in the town of Milton, and the building inspector who's on our committee with us has been tasked with determining how many of the retrofits have been Energy Star because of our stretch code. And that's something that is really just beginning to happen because it's kind of new to him and they're catching up with the data. So this is all in transition at this point. I just want to point that out, that New York was probably ahead of the curve, but we're catching up now even with all the municipalities who are, again, having to sort of change their whole process and set up new programs to track.
Yes. No, what's it?
So I live in Concord. I'm on the Sustainable Energy Committee for Concord, and this is very interesting about your residential capturing your MMBTUs at the residential level. Couple of questions. Have you communicated the total MMBTU? Is that kind of an internal number because people don't know what that number is? And do you have an overall goal for a specific time period? And do you eventually expect to do a recalculation, or are your numbers kind of so vanilla that a recalculation would not be possible? So that's an answer.
No.
Can just repeat the question?
Good for you, Jamie.
It's been communicated through an article in the Milton Times when we had our rollout of this Green Homes Milton program in the fall. We did a presentation about the data that we've kind of unearthed. We did a little program on our local cable access channel with the same information. So using those kind of venues, we've tried to get it out there. Now, whether people, when they look at it, can understand it, what an MMBTU value is, probably not, but hopefully they can see a graph that they can understand that most of the energy is coming from houses and their cars. And if they want to do something about it, they can address both of those as citizens. So in terms of following up now, after we've set the baseline, like the ICLEI protocol, of course, is now you've set the baseline, what is your plan to reduce the energy consumption? And I think our plan isn't as codified, but it is, using the weatherization programs to try and weatherize as many houses as possible. And then now the follow-up would be to see, is that work actually being done and is it effective? And those are just conversations we're just starting to have with Next Step Living and other providers, and Keith and such, to try and understand where we go beyond just understanding how much we're using. and what are realistic targets. And some of the work we're doing with our own houses and such, we've been trying to understand what's achievable, and what would be kind of like a phase change to get us to something else, what would be required there. But it has been clear that the getting adoption or enrollment in a program is very challenging. I was surprised with our mailer and other things how few people responded. And how it was a little disheartening. So, and I think part of that is as Laura said, your energy bill just isn't that big. So, if it's the same cost as your cell phone, you're not. If it was 6 times that, people would be a lot more motivated. So, the true cost of energy is a whole other thing that we can't control right now. But until that happens, our group and others thinking creatively about how you get people to participate in these programs, I think is a really significant challenge.
Jimmy, do you plan to is there a plan to redo the ICLEI inputs to get, you did 2008, was that in?
2011.
2011.
Did, yeah.
So do you plan to periodically redo that process in order to see what's happening and capture maybe behavioral or changes that you might not even know about in terms of the number of retrofits?
Yeah, I think, that would be the idea, would be to, pick a point at which we kind of do the same.
But that hasn't been baked in yet to your plan?
And part of this is keeping up with the town. I mean, they're really right in the middle of this right now, and we were hired, or we're not hired, we're a volunteer group, but we were brought on board basically by the municipality to track and help with the DOER process. I just want to mention 2 other things. I think part of the problem we have in Milton is that it is a fairly affluent town, and again, the cost issue is just really isn't there for people. And these issues of aesthetics and comfort are really, as the gentleman pointed out, are really outweighing the fact of energy consciousness. The other group I just wanted to mention is Nancy Hazard and her group out in Greening Greenfield have really been setting the standard in the state in terms of community action, and I would encourage you all to take a look at what they're doing. Nancy spoke to Nancy, she's like I remember getting Nancy, they've done incredible work that too.
Question, okay.
I have a question, maybe you touched on this before, but is there any plan to upgrade the rigorousness of the MassSafe audit? Because I had a MassSafe audit and they didn't find very much.
Yeah. So I don't know if anybody wants to take that question about
we're out of time.
the rigorousness of the MassSafe audits.
I also independently paid for a blower door test, which I had never known what it was, and the camera that shows the orange where you really notice much more than the MassSafe.
So the question was about the kind of efficiency and the rigor of the MassSafe audits. And
I'm going to pass this over to Keith and Brian. Maybe have some more. I can mention that Matt Root has been terrific in this conference. I was just organizing the whole thing, and he earmarked this session. He came to our session. We did this actually at ABX, and we refined it with his comments and Laura's comments and others. And but one of the things that we're sort of stuck with is that the CSG, which manages MassSafe, is not really able to deliver and open up the lines of information about data. And Next Step, meanwhile, which works under the program, has been much more available to do that. And I think it really breaks down in terms of doing the mass numbers that we showed you in Milton were mass numbers, they're not addresses. When you start dealing with the commercial world and companies and data, they're very sensitive about it. I think that's one of the issues that is come up in this session, and I think you guys might have some more comments.
Yeah, and I know Brian will have something to add here, but I think part of what I'm doing is to help in this process is that operational rating. You can take a rating of the home before the audit happens and then after the audit happens, and you can actually ensure that you're seeing a benefit there. So that's one of the things that I'm focused on, because that is a big issue, right? We're tracking participation, as Brian pointed out, but it's very hard to get the raw data numbers and ensure that we're seeing that energy reduction that we're hoping for.
It's particularly painful for me as a contractor doing a lot of deep energy retrofit work to be held to this extremely high bar for, you know, durability, ventilation rates, and, you know, prescriptive performance values for all the different parts of the building on the one hand, and then to, you know, witness a mass safe audit and just go, you didn't even walk into the basement, you know? So I feel your pain.
I think one of the issues that the Mass Save program deals with is there's basically it's done by private contractors. There's a certain amount of money that they get for the work. You pay a certain amount, they get a certain amount for the work, and there is a normal incentive to recommend work that is easily done and profitable. And so that's something that we need to keep addressing and working on. And I think we are actually out of time, so I think if you want to bring other questions up, the panelists will be willing to
Oh, definitely.
wait for a few minutes. I did just want to remake the announcement that at lunchtime today, Ted Benson is speaking in the Beacon Hill Room, and also to make sure to invite everybody to the closing forum, 100 years of experience, which should be really exciting. So thank you, everybody, for coming. Enjoy the rest of the day.
Yeah, thanks, Laura.